Welcome everybody to this new video about OpenGL ES. In this video, we'll be learning how to add colors and textures to our scene. So we have seen in the previous videos how we can add colors using uniforms. In this video, we will be using the vertex buffer and we will be using the glVertexAttribPointer. We will rearrange our vertex buffer to include the X, Y, and Z position of each vertex and its color, using the red, green, and blue colors. For this arrangement will be exactly as shown in this figure. So we will have vertex 1 position and color, then vertex 2 position and color, and so on. We will see how to put the stride and the offset of each one of these attributes. So basically we'll be defining two attribute pointers, one for the position, which starts at offset 0 and which has a stride of 6 floats, as you can see here, 3 for the colors and 3 for the position. For the colors, we will be using the same stride. However, the offset will be 3 floats, since we will not be starting at the beginning of the vertex buffer. For the texture, we will first need to load the bitmap from the resources. Next, we need to create a GL buffer and copy the image to it. The last step will be generating a Mipmap. I've shown in this picture here what a Mipmap means. So a Mipmap will include the texture. So assume that this is our texture here, the big image. Then it will include different scales of this image. So for example, this is scaled by 2 down. So if we started by a texture which is 512 width and height, then this would be 256, and this would be half of that, so 128, and so on. This is called a Mipmap, and OpenGL can generate that for us. OpenGL uses this Mipmap to render objects with different sizes. So imagine that our object is very big, then this full texture can be used to render this object. However, if the object is small, OpenGL will be using one of these scaled down textures. Let's start coding. We'll start from where we stopped last time. So we had this rotating rectangle here, and we have also added this camera control buttons. Let's start first by defining the colors of each vertex. And let's now run the program. As you can see, we got really messed up, since our attribute pointer is expecting a vertex each 3 floats. So we will be using this as one vertex, this is as the second, third, fourth, and so on. And that will cause this drawing that you see here in the emulator. So let's fix now our attribute buffer. So here, as you can see in the glVertexAttribPointer, the fifth input is the stride of our buffer. As you can see here, we put the stride to be the number of floats per position multiplied by the bytes per float. We need to correct this stride by adding a floats per color and setting it to 3s, since we will be having 3 floats, one for the red, one for the green, one for the blue. And we need this to be addition, sorry, not multiplication. And now we can rerun. And we are back. However, now we are not using the colors which we recently defined here. We are using the colors which we passed to the shader in the onDraw function. So here in the onDraw function, we set the model view and projection matrices, and then we are setting the color. And this is the color being used. To be sure that this is happening, for example, we can add maybe one here, and then the first rectangle will also be white. Now, to use the color that we already added in the vertex buffer, we need to change our vertex and fragment shader. Let me first copy our current vertex and fragment shaders and then change their code. I will call it color and texture. In the color texture vertex shader, we need to add a new attribute. Remember, we add an attribute using this variable this modifier in, and it would be also a vector of 3 floats, and we will call it a color. And now we don't need this uniform, which we were setting before to put the color, since we will get the color from this attribute now called a color. And the rest does not actually need to be changed. Now we are outputting this color to the fragment shader, and in the fragment shader, this color will be used to render the object. Let's now use the new shader in our code. So here on surface created, we are already defining the program which we want to use, and now we want to use the color texture. And now if we rerun, we will have a problem, since we did not define our new vertices. So as you can see, the colors now are not rendered correctly. To get the color correctly rendered, we first need to define our new attribute. So as we did here for the position, model, and the view and the projection, we need to get this new attribute. So as you can see, we use get attribute and a color. Then we need to pass this attribute to our send vertex to GL and use it there. Here in send vertex data to GL, as you remember, we have this vertex enable for position and defining the stride and offset for the position. We can add the color definition here below it. So first we enable this vertex attribute and then we define the different fields. Yeah, for the stride, we copy this from here. And the offset will be 3 floats. So those are actually the floats which we are using for each position multiplied by the number of bytes per float. And that's it. Let's run our program. Now, as you can see, we already got our new colors. Now, as you can see, you can define a color per vertex, and the OpenGL will interpolate between these colors. So you can try playing with these colors here. For example, let's put this to 0. Now, as you can see, it starts with a dark yellow and goes up to a light yellow here. Now, let's get it back to the yellow. So now you can also have this gradient effects, and if you like, you can use it in your rendering. You can see now that we can distinguish each triangle which we are drawing. So this rectangle is drawn using 2 triangles, and now even each vertex can have its own color. Okay, that's what I wanted to say about colors. Let's move now to the texture. First, let us change the vertex and fragment shader. So in the vertex shader, we need to add a new attribute for the texture. We'll call it a texture, and we will be outputting 2 variables. One is out color and the second one is out texture. And this would be only 2 floats because the texture is 2D. It only will have X and Y, or if you like, U and V coordinates. I will talk a little bit about those coordinates later. So our color will be taken as defined by the attribute pointer as before. And for the texture, we'll be defining a 2D vector and will be taken as from the X and Y coordinates, which we will pass as we will see later. Now in the fragment shader, we need to use a sampler. Let's first define the sampler. As you can see, the sampler is a uniform. It does not change per vertex. And now the final color of the fragment, we will be using the function texture. We'll take the sampler and the texture coordinate, and then we'll use those coordinates to sample from the texture which is already in the bind texture buffer, as we will see later. In this tutorial, I decided to use a color and add it to the texture. Usually you either want to use colors or textures, but it's up to you. I mean, in this tutorial, I will do it like this, and I decided to add this color as a multiplication. I mean, you can also think of adding the color and normalizing so that you keep your fragment color between 0 and 1 for each coordinate, red, green, and blue. Now, before we will be able to use our texture, we first need to select a texture. We need to copy it to OpenGL, and this is what we will be doing next. First, let us find a texture to use. So I already prepared this texture using Microsoft Paint and another one with a face on it. Let's copy these 2 textures to our resource folder. I will put them here inside Drawable. As you can see, we have now the 2 images here. First step is to add a function to load these 2 images. So I already prepared a function. Let me copy it, paste it here. So this function, I called it send texture to GL, and it will take a resource ID. In our case, would be the wall or the wall with face. As you can see, this function simply creates a handle to hold this texture. This handle will be used by OpenGL to refer to this picture later. Yeah. And now we need to load this image from the resources. As you can see, for that, we use a bitmap factory. First, we define some options, and then we use the bitmap factory function decode resource, and we need to pass the resources for that, and of course the resource ID, which is the input of this function, and yeah, as you can see here, the input of this function and the options. This will create a bitmap for us Then we need to bind the newly created texture buffer. We will define the parameter used to sample from this texture. So this, as you can see here, we are using the nearest for sampling. You can also, I think, use linear where an interpolation will be done there. That's up to you. And of course, now we copy this bitmap to the GL buffer. And remember, we said OpenGL will create for us a Mipmap, and that will be done using this function here. And finally, we can free this bitmap from our CPU side, since it's already copied to the OpenGL side. And we will return the handle for this function to be used later. And that's it. I mean, when we call this function, we already have our bitmap in a buffer on the OpenGL side. Let's call this function now twice for each one of our images in the onSurfaceCreated function. We need to define these two variables, GL texture buffer and that's it now for loading these images to OpenGL side. We already now can refer to them using these two handles. As you can see, Android Studio shows us images here whenever we refer to their ID. Let's now define the coordinates of our texture. This will be added to the vertex buffer as we did for the color, and we will add now two floating numbers here to indicate the X and Y, to indicate the U and V coordinates of the image which will be assigned to this vertex. Now, as you can see, we added two new coordinates per vertex. So now our slide has changed and we need to define a new attribute for this new defined texture coordinates. Let's do that. First, I want to take care of the stride. So for that, I want to define a new constant here, which I will call float spear texture. That would be 2. And then we go to the function send to OpenGL. Send vertex data to OpenGL. Now here we can correct our stride. So we need to add here float spear texture. Same here. And we will add a new variable here. Let's call it GL texture. And similar to the position and the color, I will just copy paste this code here and change it to use the texture. The size will be now 2, not 3. It's still float and normalized, and the stride will be the same as before. However, the offset, we need to correct that because now we not only offset it by float spear position, but also by float spear color. Now let's get the attribute location of this texture, and we need to do that in the onSurfaceCreated function. So here in the onSurfaceCreated, we're already getting the attribute location of the position, model, view, projection, and color. So we can add the texture here. Now we get this GL texture, and we need to pass it when we do this send vertex data to OpenGL. And that's it for our buffers. Now our buffer contains the data for the X, Y, and Z position, for the color, and for the texture. Now in the function onDrawFrame, we need to bind our texture buffer, which we want to use for the drawing before we do the draw operation. So here we are drawing the first rectangle. So we bind the first texture, and then before we draw the second rectangle, we bind the second texture. Now let's run the program. So we did not get the texture. That means we did something wrong. So now we need to debug. So I already have my breakpoints set as before. So as you can see here, one breakpoint has hit, and this is inside the compile shader. So there's a problem in our shaders. The problem is that a variable called cTexture is undeclared. So as you can see here, we have this cText coordinate actually, because I copy paste that from another program. What we need to do here is actually to put out texture. So this is our output from the vertex buffer to the fragment buffer. Also in the fragment buffer, we need to define our texture. So we need to take this texture here and define it as an input. And let's try to rerun. So we still hit here. There's another problem. So still this undeclared identifier, see text coordinate. So in the vertex shader, we have this A texture and we are using it to output the texture. So this should be correct. In the fragment shader, we have the output texture, and yeah, clearly I should use it also here. And this C color is also wrong since I copied it from another program. It should be out color. Sorry for this. This is usually the copy paste problems. Yeah. Let's rerun. And now we have our texture. So the first rectangle is using the first texture, and in the second rectangle we use the second texture. However, the texture coordinates are not set correctly, so we need to play with those to get really this as a rectangle showing our texture, and the same here. However, you can see that in each one of these rectangles there is one set correctly, so we need to correct the other two and get it back working. So this rectangle here is correctly set, however this one is not. So in order not to confuse you with these coordinates, I just made this picture here in MS Paint, and in this picture I put the coordinates of the two triangles which we have. So the first, this is the first vertex of the first triangle, second and third. And for the second triangle we share the same vertex here. I hope that you notice that. I mean that here is actually the same position, and they share also this same vertex. So this would be, so 1 and 4 are the same, and 3 and 5. So what we want to do now is to match the texture coordinates which start by 0, 0 and end up by 1, 1 with these two coordinates. So you get, as you can see, so 2 should get the 0, 0, 6 should get the 1, 1, and these two here should be 1 on the x, 0 on the y, and here 1 on the y, 0 on the x-axis. And now that's what I did here. And now if we run, so we already fixed this problem for the first rectangle. Let me do that for the second rectangle. And now let me rerun. And as you can see, now we fixed our coordinates. So that's all for this video. Thanks everybody, and see you.